Hello, thank you for joining me once again on this platform. Of course, we have another discussion emotion. Of course, we are still in motion. We are not done with motion, and we have another discussion at this point. And this one will be on the equilibrium of forces. This one is going to be on the equilibrium of forces. Okay, please don't forget we just finished the one that has to do with the types of motion. In that types of motion, we treated just two aspects. The one that has to do with circular motion and oscillatory motion. We only just calculated on just two. But now that is not our major concern today. We want to look at another area in this motion, and this one will be on equilibrium of forces. Okay, now let's now look at the meaning of equilibrium. We want to look at the meaning of equilibrium, and also in our subsequent teaching we are still going to look at how to resolve, how to use some certain condition to resolve equilibrium of forces, and also of course that one will also lead us to components. Okay, let's now look at the meaning of equilibrium. A body is said to be in equilibrium if it continues its state of rest or its state of uniform motion. A body is said to be in equilibrium if it continues its state of rest or its state of uniform motion. And there are two categories of equilibrium. And they want to look at it. And this one will be the one that has to do with static equilibrium and dynamic equilibrium. We already know the meaning of the word static. The word static, we have looked at it before. We also look at the one of dynamic. Of course, we also look at the one of dynamic. Okay, now let's now look at these two categories: static equilibrium and dynamic equilibrium. If a body is at rest and remain at rest, then the equilibrium is said to be static. If a body is at rest and remain at rest, and this body remain at rest, then the equilibrium is said to be static equilibrium. But if a body is initially moving with some velocity and continue its motion rectilinearly with the same velocity, or if the body is rotating with some initial angular velocity and the angular velocity remain constant, then the body is said to be in dynamic equilibrium. If the velocity and angular velocity of the body, either zero or non-zero, remain constant with time, then acceleration and angular acceleration are zero. For rectilinear motion, if the acceleration is zero, then by Newton's second law, the net force is also zero. Similarly, for rotary motion, if angular acceleration is zero, then by Newton's second law, for rotation, net torque is also zero. Net torque is also zero. We also have other classes, meaning we can see that equilibrium can further be classified into other aspects, into other areas, and this one has to do with translational equilibrium and rotational equilibrium. It means that in my next line of discussion, that in my next class, we are going to look at these two other classes of equilibrium. Okay, we are going to look at these other two classes, that is translational equilibrium and rotational equilibrium. Of course, this one will be on the static equilibrium, and it's going to be on static equilibrium, and we are going to look at it on static equilibrium. Meaning my next line of teaching or discussion will be on static equilibrium, not dynamic equilibrium. I'm going to focus on static. Okay, this is just the little introduction I have for you on equilibrium. And of course, in this equilibrium of forces, we are going to look at how to use some certain conditions to resolve it, and also looking at components, of course, looking at component. I remember we have treated on component before. We are going to look at it. Okay, now I think I can draw my conclusion here, and please don't fail to like my page. Don't fail to like my page. Some of you just go to my page, you don't like the page. Please don't fail to like the page, like my page GB Jumbo Online Mathematics, and also don't forget to subscribe to my YouTube channel, Mathematics Science Mega Tutorial. All the best. Thank you. God bless you.